Hi everyone, today we are going to see the types of sets. The first one is empty sets, equal and unequal sets, finite and infinite sets, subsets, power sets and universal sets. Now we'll discuss about each and every sets one by one. First we are going to see empty sets. First of all, we have already seen what is a set. A set is a well-defined collection of objects. So the objects in a set, each object we name it as a element. So if in any set that does not contain any element in it, then it is called a empty or null or void set. So we symbolize this empty set with the empty curly braces. See, you have curly braces, open curly braces and closed curly braces. Inside the braces you have nothing here, so this refers to empty, and a slashed 0. So these symbols we are using to represent the empty set. Next we'll see the example of empty set. You have set A which contains x such that 9 less than x less than 10. X is a natural number. So see, for natural numbers we know that it starts from 1, 2, 3, 4, 5 and so on. It goes infinite number of natural numbers. They have given here x is a natural number between 9 and 10. We know that 9 and 10 are natural numbers, and between the natural 9 and 10 you don't have any natural numbers. So there are no natural numbers between the numbers 9 and 10. So set A is a null set. So A is equal to, you can write it as the empty braces or a slashed 0. Next we are going to learn about finite and infinite sets. So any set which is empty or contains a definite and countable number of elements is called a finite set. So if it is a finite set, we can count the number of elements. So if we can't count the number of elements, we can say that it as infinite sets. We'll see the example. So for finite set, set of all English alphabets. So set of all English alphabets is, there are 26 alphabets. So we can say that it is a finite set. English alphabets are countable. So it is a finite set. Example for infinite set is set of odd natural numbers. Say we say natural numbers, we start from 1, 3, 5, 7 and it keeps on going. So we don't know the natural numbers. There are infinite natural numbers. If we say, we can say the natural numbers till 10 or till 20, you can say that as finite. But here it is given as set of odd natural numbers. They have not given any condition that till which number. So this is a infinite set. So for infinite set, they have a, inside the curly braces you have to write the dot dot symbol. Now we are going to see the equal and unequal sets. So if you have x and y are two sets, if the elements in the sets are equal, we can say that it is a equal set, irrespective of the order of appearance. If x has 1, 2, the y can have 2, 1. So the elements 1 and 2 are same, but the places are different. So irrespective of the order of appearance in the set, x and y, the elements should be same. If the elements are not same, or if you in the place in the set x you have 1, 2 and the y set contains 1, 2, 3, only the 3 is the difference. So if one distinct element is there, you can say that x is not equal to y. They are unequal sets. So we represent equal sets as x equals to y and unequal sets as x not equal to y. So this is the symbols we are using. Next we are going to see the examples now for equal and unequal sets. So x is a set with a, e, i, o, u. So these are vowels, we know that. See, here they have given a set h which has o, u, i, a, e. See, here you have a, here also you have a, here e, and this set contains e. Here you have I, here also I, O, U. Here also O, U. So all the elements are same in both the sets. Hence, we can say that they are equal sets. X and H are equal sets. Now they have given C and D. See, here you have 1. Here D set also has 1. C has 3. D also has 3. C has 5. D has 5. And here it is 7. And here it is 9. So, the last fourth element is not same. So, C and D are unequal sets, and we represent that C is not equal to D. Now we are going to see an important type of set, that is subset. So a set A is said to be a subset of set B if all the elements of set A are also present in set B. So we'll see here example. If set A has xy and set B has xyz. So if set A, if we want to say that set A is a subset of set B, so these elements in the set A should be contained in B. See, here you have x and y. Here x, y is there. So A is a subset of B because the elements x and y are present in the set B also. So A is a subset of B. We write it with this symbol. See, here you have a C, right? C like symbol. This symbol we use for subset. We have to read this as A is a subset of B. Now, if the elements elements are not in B, we can say that is not a subset of B. See, here you have an example. Set A is equal to 1, 3 and 5. Here set B is 2, 4, 6. Element 1, 3, 5 are not present in the set B. So we can say that A is not a subset of B because elements of A are not present in B. And we represent this as the symbol is the C. Here we are writing here in the C form, right? The symbol, it should be crossed. So we read this as A is not a subset of B. Now we are going to see a real life example for understanding the subsets. So we are going to an ice cream parlor. They have different kinds of ice cream. So here for example we take butterscotch, chocolate and strawberry. So if you are asked to select any one to have, you can select butterscotch, either or chocolate or strawberry flavor. So you have 3 ways to select. If you are asked to select any one, you have 3 ways. So if you are asked to have any 2 at a time, so if any 2 at a time, you can select butterscotch and chocolate together, or you can select chocolate and strawberry together, or you can select butterscotch and strawberry together. So if you are asked to have any 2, you have 3 ways to select. If you are asked to select any 3 at a time, so only one option, you can have all the 3 together. So you have butterscotch, chocolate and strawberry together. Okay, if your doctor has advised you that you should not eat ice creams, what you will do? You will not have anything. So none. So we represent it with empty sets. So now the original set we are looking for is butterscotch, chocolate and strawberry. This is a set of all kinds of ice creams we could choose from. So all the sets on the right hand side. So all the sets on the right hand sets are the part of the main set. So all the sets are the part of the main set. So each set here is a part of the main set. That is, B is a part of this entire set, CS is a part of this entire set, and the 3 butterscotch, chocolate, strawberry, these are also a part of this entire set. And the empty set, none, is also a part of the entire set. So in mathematics we say that each set is a subset of the main set. So each set, this is a subset of the main set. So general we say that it is a part of, and in mathematics we say that it is a subset. So we must remember that empty set is a subset of the entire set, and the entire set BCS here, right? This is also a subset of the entire set. So this is how we write the subsets. So the empty set, entire set, and the parts, these subsets, these are all the subsets of the entire set. So now we'll write it with the mathematics sets. So here we have given the sets A, B and C. So we know that first we need to write the empty set is a subset of A, B, C. So first, for writing the subsets, you must write the empty set first. Then you can write the whole set. So the given set you should write it as it is. Now the other sets we can write. First we'll write the empty set, then we will write the single set, that is A, B, C, then two sets, that is AB, AC, BC, and the entire set. So this is how you write the subsets. Now we are going to learn about the power set. So a power set is a set of all the subsets of a set. So for in the previously we learned to write all the subsets of a set. So power set is the set of all the subsets of a set. It is denoted by P of A. So if given a set A, we can write it as P of A. If the set is given as S, we have to write it as P of S. So the inside the bracket, this letter will be changing for each and every set. So if A is a set with n of A, so number of elements is equal to m, then the general form is n of P of A is equal to 2 power n. So last example, we found the subsets of A, right? So first we'll write all the subsets of the set A. That is empty set, set singleton set, AB, AC, BC and ABC. So for writing the power set, n of P of A is equal to 2 power 3. Here you have 3 elements. So we have to write 2 power 3. So 2 power 3 is 2 into 2 into 2 is 8. So this is how you find the power of the set, power sets. Now we are going to learn about the universal set. Universal set is a set which contains all objects including itself without any repetition of the elements. It is denoted by the symbol U. Example is, let set A is equal to 1, 3, 6, 8, set B is equal to 2, 3, 4, 5, set C is equal to 5, 8, 9. So here it is given as contains all objects including itself without any repetition of elements. So we should not repeat the elements again. If the element is written 2 times, we should write it only 1 time. So the universal set is equal to, we are going to write all the elements in the set A, B and C. So 1, 3, 6, 8, 2, 3, 4, 5, all the elements will make the set U. But here you see 3 is 2 times here, so we should write only once, and 8 is 2 times here, we should write only once. 5 is 2 times here, so we should write only 1, 5. So set U is equal to 1, 3, 6, 8 and 2, 3 is already written, so we are leaving. 4 we are writing, 5 is written, 5 is already written, so leave these 2 and writing the 9. So this is the universal set. So we have learned the different types of sets. So if you like my videos, please subscribe to my channels and share the videos to your friends too.